Welcome to our deep dive into the unsettling repercussions of a changing planet. With global warming on the rise, unforeseen consequences are beginning to unfold. In this video, titled "The Impact of Melting Permafrost on Global Ecosystems," we will unravel the intricate details of permafrost and the potential threats its melting poses to Earth's ecosystems, biodiversity, and even human health. Get ready to explore a less talked about but critically significant factor of climate change: the melting permafrost. 1. Understanding permafrost and its global distribution. Permafrost, a layer of soil that remains frozen year-round, covers an impressive 24% of the northern hemisphere. It stretches across wide swaths of Siberia, Canada, Alaska, and parts of Scandinavia. More than just a frozen crust, it encapsulates millennia of organic material, essentially acting as a massive time capsule. This makes permafrost a significant player in Earth's carbon cycle. Even a slight uptick in global temperatures can ignite this icy layer, releasing trapped carbon and setting off a domino effect in ecosystems across the globe. Such is the precarious nature of permafrost in today's warming world. 2. Historical context. Permafrost stability. Over time, permafrost has historically been a stable anchor of Arctic environments, broadly dictating the region's ecological balance. Insights from paleoclimatic research show how sensitive permafrost is to temperature changes. Previous warming epochs unlocked vast amounts of carbon, spurring a climate shift. By studying these historical patterns, we gain an understanding of the broader implications of current permafrost thawing. The transformation during these periods reveals just how quickly ecosystems can pivot in response to thermal fluctuations. 3. Carbon release and climate feedback mechanisms. Frozen permafrost is Earth's refrigerator, storing between 1,460 and 1,600 billion metric tons of organic carbon. This is nearly double the carbon content of the current atmosphere. However, as the permafrost warms and softens its grip, microbial activity intensifies. This leads to the release of significant quantities of carbon dioxide, CO, and methane, carbon tetrahydride, both potent accelerators of global warming. This phenomenon is described as a positive feedback loop, where warming begets more warming, amplifying the challenges we face with climate change. 4. Impact on Arctic ecosystems. A thawing permafrost transforms the Arctic landscape visibly and rapidly. Once stable tundras can morph into sprawling wetlands, while entire ground sections may collapse, a process known as thermokarst formation. These shifts disrupt the homes of numerous plant and animal species, forcing them to adapt or face extinction. New aquatic ecosystems may form, yet they bring along significant releases of methane. This plays havoc both locally and on a scale that impacts global climate systems. 5. Hydrological changes and water quality. The repercussions of melting permafrost extend distinctly to water systems. Thawing alters river flows, often increasing sediment and nutrient loads, significantly affecting water bodies' visual and ecological quality. In Alaska's Brooks Range, crystal clear rivers now tote murky waters, showcasing the underlying mineral transformations. These alterations threaten the aquatic life thriving there and pose direct challenges to communities reliant on these water sources for sustenance and livelihoods. 6. Release of ancient pathogens. One of the more unnerving consequences of permafrost thaw involves ancient pathogens. These frozen grounds encapsulate dormant bacteria and viruses, some dating back thousands of years. While reanimated pathogens pose potential health risks, they also remind us of the broader unknowns tied to permafrost melt. Sporadic incidents have sparked genuine concern, emphasizing the need for heightened monitoring and understanding of potential risks. 7. Infrastructure challenges in permafrost regions. In regions where permafrost serves as the bedrock for infrastructure, challenges become immediately tangible. Places like Siberia and Alaska have infrastructure, roads, buildings, pipelines, rooted in frozen ground. Thawing can undermine these structures' stability, causing dangerous subsidence and damage. Notable events like the 2020 Norilsk oil spill in Russia highlight these perils, as it resulted from a collapse due to thawed permafrost. 8. Global implications of permafrost thaw. The domino effect of melting permafrost extends far beyond polar regions. Increased greenhouse gas emissions play a key role in warming global temperatures, displacing weather patterns, raising sea levels, and generally altering ecosystems worldwide. Unsurprisingly then, comprehending the breadth of these consequences paves the way for effective strategies to counteract these symptoms of a warming Earth. 9. Mitigation and adaptation strategies. Combating permafrost thaw involves juggling several approaches. Mitigation focuses on reducing greenhouse gases to decelerate global warming and stabilize permafrost. On the flip side, adaptation requires innovative infrastructure design, continuous monitoring, and eco-friendly land use practices to curb disturbances. Critical to these solutions is the cooperation across nations, appreciating indigenous wisdom, and fostering collaborative responses to ensure future resilience. 10. Conclusion. Permafrost, though often unobserved, acts as a silent yet critical component in Earth's ecological balance. As it thaws, the impact radiates through ecosystems, economies, and societies. While the situation presents complex challenges, embracing a holistic understanding entwined with urgent action will be paramount to navigating this contemporary menace. The thick layer of ice knows no borders, prompting a call for global collaboration for an uncertain yet vital future.